Okay. Last week we learned about specific heat capacity. What you mean by the low specific heat capacity? And what is mean by high specific heat capacity? Yes, Sabrina?
Low specific heat capacity means dia boleh panas cepat.
Ya, panas cepat dan sejuk pun cepat.
Hmm.
Sebab
Kalau high specific heat capacity dia boleh panas cepat, sejuk lambat.
tak high specific heat capacity ni lambat panas, lambat sejuk. Dia lambat. It's like let's say you have a car and a bus. Car ni cepat untuk fill up with the passenger and cepat kita nak drop out. Kalau a bus of people, imagine. Okay, it very late to make fully occupied and very late to get rid of them lah. I mean, drop them out. Okay, so you imagine like a car and a bus. Okay, so low specific heat capacity, cepat panas, cepat sejuk. High specific heat capacity, lambat panas, lambat sejuk. Okay, now low specific heat capacity. For example, metals and alloys. Okay, alloy ni it's like improved version of the metal lah. You not yet learn, I think. You will learn this in your chemistry. Alloy macam copper saja kan. Kalau copper saja, dia boleh easily bengkok. Okay, so you will add copper with zinc. Copper with zinc, it will create an alloy like a bronze. Okay, itu maksud alloy lah. The normal metal, the pure metal, you add another metal inside or another elements. Okay, low specific heat capacity, heat up and cool at faster rate. For example, metal like iron, steel, copper, aluminium is used as a pot and a pan because they can be quickly heated up when there is only a small heat absorption. They are also sensitive to temperature changes. A thermometer has low specific heat capacity, so it enables heat to be easily absorbed and released even when small quantity heats are involved. Okay, for example, our mercury lah, what they meant. Mercury inside the thermometer. They are very sensitive to temperature because it has low specific heat capacity. Kalau high specific heat capacity, normally water, plastic, wood, heat up and cools at a slower rate. Okay, so require more heat to raise its temperature by a specific amount. This is useful to make the poor conductor of heat material like handle of the pot. Okay, the body must be low specific heat capacity. Dia punya pemegang high specific heat capacity. Tak cepat panas lah. Dia lambat panas. So, another advantage of high specific heat capacity is it can absorb great amount of heat without a high increase in temperature. Okay, you don't need a very high temperature. It will absorb slowly and then it contain more heat. Because you imagine a bus and a car, right? Okay, a bus, the number of people going to occupy is more than the car. The car only can occupy 4 to 5 people. But this one bus can be about 45 people. The number of people is like analogy for the amount of heat energy you can store. So for example, water act as a heat reservoir. Simpanan tenaga haba. Reservoir ni maksudnya simpanan lah. Water acts as a heat reservoir as it can absorb great amount of heat before it boils. Water is used as a cooling agent in car radiator, for example, because water is a high specific heat capacity material. Okay, dia akan simpan banyak haba baru dia boil. Bukan sikit-sikit nak boil. Kalau sikit-sikit nak boil, kita tak boleh guna dalam radiator. Kalau sikit-sikit dia boil, nanti dia easily vaporize, nanti kehilangan air banyak, nanti radiator tak boleh cooling lagi. Jadi, radiator boleh rosak lah due to overheat. You understand the significance of water?
Yes, sir.
Okay, good. Now, application of specific heat capacity. Baru cakap tentang radiator. Okay, kita tengok. Kita kena belajar sea breeze, land breeze. Okay, a few. Radiator dengan water coolant in a car engine is almost the same. And then cooking pot. Okay, kita akan tengok one by one. Okay. The first thing, kena hafal tak macam ni semua? Okay, tak payah hafal, cuba fahamkan. Kalau dia mungkin boleh tanya dalam essay format. Explain how the water act as a thermal radiator, heating agent in a thermal radiator. Then you need to, they will label for you a certain parts using, the label means that is important. That is a clue for you. Okay, and then you just create your own story. That's it. Okay, but thermal radiator is this one is the thermal radiator ni bukan dalam car radiator. Car radiator is different. I give you here the car engine here. This thermal radiator is basically used by the cold countries to heat and keep the house warm. For example, inside an igloo. Okay, like that. So they will normally have satu takungan air lah, air panas. Okay, hot water carrying the heat from water reservoir flow to the radiator. Macam aircon dia ada hot con lah. Okay, so hot air, it carry the heat towards the radiator. This radiator must be in black color. Why? Black color, good heat absorber and good heat radiator. Dah belajar dalam form 2. It is a good heat absorber and good heat radiator. So, heat is given out from the radiator to warm the air inside the house. Okay. And then, the cold water, after it radiates the heat, only the heat will be radiated. The water molecules become, after you radiate the heat, the water become cold, you know. So the cold water flow back into the water tank. And then at water tank, cold water is reheated and the cycle is repeated continuously. Macam tu lah lebih kurang. Okay, this one clear? Any question?
Sir,
Yeah.
I don't understand the second one.
Second one. Okay. Di sini dia bawa macam boiling water lah. Not to say boiling, like a 70 to 80 degrees Celsius of water.
Air panas.
Air panas. Air panas tu dia bagi keluar steam saja. Air itu kekal di sini. Kalau steam dah keluar, dia dah radiate the heat, right? So it become cold, correct or not? Then the cold water go back to the tangki.
Okay.
Lebih kurang macam tu lah. Okay, can understand
Okay, sir.
Okay, next one is sea breeze. Kita ada sea breeze, land breeze dah belajar masa form 2 juga. But that one we learn in terms of convection. The heat transfer through convection. But when you go to SPM, we don't want to see the convection part. We want to see more towards the how you relate with the specific heat capacity. Okay, sea breeze maksudnya breeze tu dari laut pergi ke land. Laut pergi ke land. Okay, the movement of cool air from the sea to the land as a result of hot air that is rising from the land in the daytime. Okay, right. For example, during the daytime, heat energy from the sun is absorbed by the sea and the land. Dua-dua pun absorb. Okay. Tapi kena ingat, between the land and sea, land always have the low specific heat capacity. Sea water contain high specific heat capacity. Sebab dia water kan. Okay. Another thing, sea is more than the land. So, that's why it have a high specific heat capacity. Okay, number 2. Sea has a high specific heat capacity. Jadi temperature increase dia slower. As a result, sea is cooler than the land. Okay. On the other hand, land which has a lower specific heat capacity experiences rise in temperature very fast. As a result, land is warmer than the sea. Okay. So, hot air above the land rises. Sebab kita tengok yang mana lebih panas, dia udara dia akan jadi kurang tumpat. How to tell? Less dense. Always remember that warm air less dense. Cold air denser. So, kita dah tengok warm land, jadi warm air dia akan naik atas, hot air above the land rise. So, dia dah kehilangan udara kan? Jadi, udara dari sea ni dia pergi ganti kehilangan udara di land. Okay? Number 5. Cooler air above the sea move towards into the land to replace the air that is lost on the surface of the land. You dah faham cerita, you boleh create your own cerita. I mean, with the fact lah. Okay? So, I wrap up one more time. So, during the daytime, you must mention sea breeze is only happen during daytime. Okay? During the daytime, heat energy will hit the the land and the sea. The sea, which has a higher specific heat capacity, will have a slower increase in the temperature. While the land, which has a lower specific heat capacity, will have a increase in temperature in faster rate. So as a result, land is warmer than the sea. So the air above the warm land will rise up, no need, rises. Rise mean dah atas kan. Rises. The cold air from the sea move towards the land to replace the hot air that has been lost. Okay? Lebih kurang macam tu lah. Can understand sea breeze?
Okay, sir.
Okay, very good. Question macam ni, dia selalu keluar explain lah. You explain sea breeze, land breeze untuk 4 markah. Teori semua, yang ni semua dia test untuk 4 markah. Kena ingat. Jangan sesekali hafal. Kamu hafal dia punya key point saja sudah cukup. Cara dia explain, lepas tu guna kamu punya own English to tell out all the points. Okay, land breeze. Land breeze ni, land breeze daripada darat. The movement of cool air from the land to the sea. As a result, hot air rising from the sea during the night. Okay. Why like that? Okay, let's see. During the night time, heat is lost from the sea and the land. Dua-dua pun kehilangan haba. Tetapi, where is number 2? Your land, which has a lower specific heat capacity, will cool off faster. While your sea, which has the higher specific heat capacity, will cool off slower. As a result, land is cooler than the sea. So, or you can tell the sea is warmer than the land. Biasa untuk land breeze kita guna cool lah. Maksudnya land cool, maksudnya sea tu warm lah. Jadi, the hot air above the sea rises. The cooler air from the land move towards the sea to replace the hot air loss. Same thing, terbalik je. Tadi dia jadi siapa cepat panas? Land. Di sini siapa cepat sejuk? Land juga. Okay, kalau land sejuk, sea dia panas, jadi udara atas dia naik atas. Udara dari land pula gantikan udara panas yang hilang tadi. Okay, clear land breeze? Any question?
Okay, sir. Clear.
Okay, very good. Traditional house. Kita dah tahu kan tadi, wood has a very high specific heat capacity. Heat up slowly, suitable to be used to build house in the warm weather region. In cold region, wood act as a good insulator to reduce heat from the inside the house from escaping outside. Okay, apa yang dia maksudkan? Kat Malaysia je, kat Asia je lah, bukan Malaysia lah. Asia je, dia banyak rumah tu dia bina daripada batu. Tapi kalau kita pergi, kita tengok watch the Hollywood movie ya, cerita-cerita hantu dia, kamu tengok rumah dia biasanya dia adalah papan, rumah papan. Because it's not like it's a symbolize they are poor, no. Because of the weather. They cannot build the house with the batu bata because this batu bata ni cepat panas. Kalau kayu ni lambat panas. Okay? High specific heat capacity. Jadi in weather region, it will take a longer time to get warm because it have high specific heat capacity. In cold region pula, wood act as a good insulator. Kenapa? It take a longer time to cool off. So it will keep the warm inside the house. So act as a good insulator of heat lah. Okay? Right. Can understand the traditional house?
Can, sir.
Okay. Next. Yang ni. Okay. Outer layer of space capsule. Space capsule entering the Earth atmosphere. Capsule tu maksudnya dia macam kapal angkasa lah. Dalam kapal angkasa dia ada satu macam roket kan. Ini adalah satu capsule. Dia ada banyak. Okay. Right. Space capsule entering the Earth atmosphere has higher air resistance, causing its temperature to increase. The outer layer of the space capsule is made of material with very high specific capacity and melting point, so that it not easily burn lah. Okay, because when you moving against a high resistance, it causes the temperature increase so fast. So to reduce this effect and to avoid the burning of capsule, you need to create your capsule with a very high specific heat capacity material and high melting point material. Same like satellite also. Okay. Next is the construction of green building. Roof is fitted with insulator made up of styrofoam. Styrofoam ni macam, okay, wait, let me show. Styrofoam. You need to see first, then only you know. Macam ni, dalam helmet pernah pakai? Helmet.
Pernah?
Dalam tu dia ada macam kapas, strong polystyrene, right? Macam tu lah styrofoam.
Oh, okay.
Macam polystyrene lah, kita cakap. Polystyrene dengan styrofoam is almost the same. Example polystyrene lah, benda tu polystyrene. There, this is a styrofoam. Polystyrene lah. Okay. Roof is fitted with insulator made up of styrofoam inside it. High specific heat capacity of the material can reduce the absorption of heat from the surrounding to reduce the temperature inside the building. Kamu letak styrofoam di sini. Yang ni dia kat high specific heat capacity. Jadi dia tak cepat panas. Semua heat from the bumbung ni dia transfer dekat styrofoam, tapi styrofoam ni dia lambat absorb heat. So it reduce the temperature inside the building. Okay, right. Next one. Next one, the most anticipated one. The ni water as a coolant in car engine. Yang ni biasa dia tanya dalam essay ya. Dia akan tanya berapa biji bila fan yang kita, berapa biji blade yang kita kena pasang, air kena air ke atau benda lain kita guna untuk coolant, and then the radiator must be big or small. Dia akan tanya semua benda ni. Dia ada keluar soalan 2000, dia ada 2 kali keluar. Masa exercise nanti saya include together lah the exercise. Okay, right. Burning of fuel in car engine produce large amount of heat. This heat need to be released to avoid overheating the engine. So water has a high specific heat capacity and it is used as a cooling agent. Okay, how does it work? Okay, a pump will pump the water. A pump will pump water into the engine block. Okay, ke dalam engine and water will flow through the engine block to absorb the heat produced. Okay, pump dekat sini ya. Okay, dia akan masuk dalam engine block dekat sini semua. Dia masuk. Masa dia masuk, dia absorb the heat dan dia keluar balik lah. Keluar balik dekat sini. Maksudnya heat tu, the heat energy is very it is a heat energy, right? It's a very hot air. The hot air come here. At here we have a cooling fan. Hot air tu akan release lah. Okay. A pump will pump the water into the engine block. Water will flow through the engine block to absorb the heat. Hot water flow towards the radiator dekat sini. Cold air is sucked in. Okay. So that the heat in the hot water can be released quickly. Dia release the heat lah. Can understand?
The cold air is sucked by fans means?
Dari luar. Ni dia panas kan? Dia dah masuk radiator. Radiator dekat sini kan? Masa tu memang enjin kita akan merangkap udara dari luar. Dari luar. Dekat sini panas. So, the cold air will remove the heat lah.
Oh, ambil angin dari luar, sejukkan yang dekat dalam.
Udara panas, ya.
Oh, okay.
Lepas tu, the water flow balik. Understand?
Faham.
Dia constantly become hot and then cool by the cold air. Macam tu lah. Okay, finally, cooking pot. Ini pun dia orang suka tanya ini dalam question 7 and 8 of your structure. 7 and 8 biasanya dia akan bagi, question 7 dia akan suruh modify. Question 8 dia akan bagi 3 pilihan. Pilih yang best tapi kena bagi reason. Making decision. Okay, ini question 7 modify. Tapi dalam bentuk struktur. Kalau essay, section B, make decision. Section C, tak ada pilihan, modify. Okay, right. Cooking pot. The body must be aluminium body. Why? Low specific heat capacity, so it become hot quickly. The body also must be low density, so that it is very light. Does not react with the food in the pot. That's why we choose aluminium body. The handle. Handle is made up of synthetic material like plastic or the wood. High specific heat capacity, it will not become too hot when the heat is absorbed. And at the same time, it is also poor conductor of heat. Very little heat from the pot is transferred to the hand of the holder. Dia tak boleh absorb banyak heat. So, kita save lah untuk pegang dia. Base dia pula dekat sini, made of steel. Low specific heat capacity, so for the same reason, it become hot very quickly and enable the quick cooking of the food in the pot. Jadi kalau kita macam zaman dulu kan, dia orang semua masak dalam belanga. Tahu apa tu belanga?
Tak tahu.
மண்பானை.
Oh, okay.
அதில் ஆக்குவாங்க.
Oh.
ஓகேயா, அது வந்து அந்த மாதிரிலாம் ஆக்குனாங்கன்னு வச்சுக்கோயேன், 12 மணிக்கு ஆக்கிட்டு நீ 3 மணிக்கு வந்தாலும் கறி சூடாக தான் இருக்கும்.
Oh, high specific heat
Yes,
capacity.
very good. High specific heat capacity. Because dia lambat sejuk, dia lambat panas. Memang cooking time dia akan ambil masa, tapi dia tak cepat sejuk. So it like ever heat lah. Okay, so அந்த மாதிரி இருக்கும். But very dangerous also use manpana this time because we don't know got any contaminated with the microorganism or not. There is a good side and the bad side lah. Some people tell when you cook with the normal cooking pot, it may cause cancer. I don't know which one to believe because I never do a proper research on that lah. Okay, some people they pro to this our traditional way, and another group of people telling the normal that we are using the modern cooking pot is enough. Okay, right. Anyway, so that's all about the specific heat capacity. So you understand everything?
Yes, sir.
Okay, good. Especially you must know how to do the calculation when you mixing up things. No need to expect the question like example 11 lah. That is that is too complicated. Okay, but you must expect the question like example 10, mixing two different substance and also mixing two similar substance.
Okay, sir.
You dah cover dekat apa yang saya bagi ni dah cukup, tak perlu search for the other type of question. I will include whatever type of question that look different, I already include here already. Okay, next one, 4.3. 4.3, specific latent heat. Okay, specific latent heat. Okay, learning standard itu penting. Sebab apa? Kita kena tahu apa yang kita nak belajar. Okay, explain latent heat. What is a latent heat? Define the specific latent heat, and then specific latent heat of fusion, specific latent heat of vaporization. Experiment to determine the specific latent heat of fusion of ice and specific latent heat of evaporation of water. Communicate to explain the application of specific latent heat in daily life. Solve problem involving latent heat. So saya punya nota berdasarkan learning standard saja. Okay, latent heat. How to explain latent heat. Okay, kita tengok. Matter can exist in three phases or three states. We call solid, liquid, and gas. For example, water molecule can exist in all three types of state. As an ice in solid, as a water in a liquid phase, and as a steam in a gas phase. A change in the phase of matter from one phase to another occur at a very specific temperature. That is what we call at the freezing point, boiling point, melting point, macam tu. And pressure. A change in phase normally occur with the absorption or release of the heat. Betul lah. Solid dia nak jadi liquid mestilah absorb heat. Tapi liquid nak jadi solid mestilah release heat. Okay. So definition of latent heat. The heat absorbed or the heat released at constant temperature during the change of phase. Maksudnya dia punya phase dia akan bertukar, state of matter, phase of matter constant temperature. At constant temperature. Tapi temperature tak berubah. Bolehkah? Boleh. For example, you take an ice. The ice is becoming water through melting, right? The ice freeze at 0 degrees Celsius. Melting pun 0 degrees Celsius. Remember, freezing point and melting point of an ice is the same. Temperature dia sama tetapi dia punya state of matter dia berubah. Ini yang kita cakap specific latent heat. Same for the water becoming steam. Water can go up to 100 degrees Celsius. And steam is also 100 degrees Celsius. The boiling point. Water can heat up until 100. So, the temperature doesn't change, but the phase of matter change from water to the steam by boiling. Or through reverse process also it's true. Okay, it condense also at the 100 degrees Celsius. Temperature tak berubah tetapi phase of matter is changing. Then we call this is a latent heat. Cuma kita bagi nama yang special sikit lah. Kalau ice menjadi water atau water menjadi ice, kita cakap latent heat of fusion, LF. Kalau water become steam atau steam becoming water, in another word, liquid become gas or gas become liquid, we call latent heat of vaporization. Yang tu specifically we tell lah. But overall, latent heat ni maksudnya heat absorb or heat release at constant temperature during change of a phase. Okay, for example, solid becoming liquid or liquid becoming solid at a constant temperature, we call it latent heat of fusion. Kalau liquid becoming gas or gas becoming liquid, we call it latent heat of vaporization. Can understand?
Can, sir.
Okay, good. Now, back to specific latent heat. Specific latent heat, simbol dia adalah L lah. Kalau kamu tak suka guna L kecil, kamu boleh guna L besar. Tak kisahlah. Boleh je. It's just a notation. Sebab biasa saya tulis masa saya form 4, saya tulis ML. Macam ni. Because sometimes yang ni nampak macam I untuk saya. Okay, it doesn't matter. It's just a notation. Quantity of heat that is absorbed or released during a change of phase of 1 kg of substance without any change in its temperature. Ini keyword dia. You break down into 3 parts. Quantity of heat that is absorbed or released during a change of phase of 1 kg of the substance without any change in its temperature. Apa yang kena ubah, apa yang tak kena ubah. Senang saja. Okay, specific latent heat ini, heat that is released or absorbed during, apa yang berubah? Phase of matter, right? So, a change of phase of 1 kg substance, apa yang tak ubah? Temperature. Without any change its temperature. So, the Q is heat energy lah kan. Jadi, joule lah dia punya unit. M to mass, kg. L to specific latent heat. Okay, specific latent heat. Jadi, kita tahu specific latent heat ni very specific to a substance. Ada 2. Specific latent heat of fusion, specific latent heat of vaporization. Kita tengok. Specific latent heat of fusion. Fusion ni apa dia? Either melting or freezing. Okay, tapi kita guna ikut textbook. Quantity, dia punya definition copy je lah, same. Quantity of heat absorbed or quantity of heat absorbed during melting. Oh, dia mention dua-dua. Okay, quantity of heat absorbed during melting. During melting kita absorb heat kan. Ataupun the quantity of the heat released during freezing of 1 kg substance without any change in temperature. Must mention that at last. But this definition I never tell without changing the phase of without with changing the phase of matter, right? But you already tell melting, freezing, it already means change of matter, change of phase. So tak payah kamu letak change in of phase. Okay? Sebab melting dengan freezing sudah membawa maksud your phase is changing. Just mention the temperature does not change. Quantity of heat absorbed during melting or quantity of heat released during freezing of 1 kg substance without any change in temperature. Okay, so dekat sini specific latent heat of fusion, solid becoming liquid. Kalau liquid nak become a gas, it is either boiling, liquid become gas, or gas become liquid. We call condensation. That one we call specific latent heat of vaporization. Quantity of heat absorbed during the boiling, okay, or the quantity of heat released during the condensation of 1 kg of the substance without any change in temperature is known as specific latent heat of vaporization. Boleh faham in terms of definition?
Boleh sir.
Okay, very good. Next போலாம். Next வந்து experiment to show specific latent heat of fusion. Because it is part of the syllabus, so I just show you experiment காட்டியிருக்காங்க. I don't want to show you the procedure, everything all. இது எப்படி செய்வாங்கன்னு you tengok gambar dan dia punya table sudah tahu. Okay. First of all, you நம்ம வந்து ஒரு இதை வே பண்ணுறோம். ஐஸ் கட்டி இதில் போட்டிருக்கோம். Okay, crushed ice in a filter funnel and then you place an immersion heater. ஒரு ஹீட்டர் எடுத்து இதில் போடுறோம். ஆரம்பத்திலேயே முதல்ல இந்த வாட்டர் எவ்வளோ மேஸ்ன்னு பார்த்துக்கிறோம். let's say it's 100 gram. ஓகே, இந்த ஐஸ் வந்து மெல்ட் ஆகும்ல நம்ம ஹீட்டர் ஆன் பண்ணோன்னே. அதுக்கப்புறம் திருப்பி நம்ம ரீவே பண்ணணும். ஓகேயா, ரீவே பண்ணணும். இதை வச்சு நம்ம அதோட ஸ்பெசிஃபிக் latent heat of fusion கண்டுபிடிச்சிடலாம். Fusion is melting or freezing, remember. So for example, let's say 100 gram initial water. அப்புறம் மெல்ட் ஆகி முடிஞ்சோடனே 0.3 katakanlah 0.3 kg lah, maksudnya 300 gram of water. Okay, so the power of the heater, let's say biasa berapa watt? Kejap, kita curi dari soalan. Kita letak 100 watt. Let's say it's 100 watt. Masa pemanasan, let's say 20 second. 20 second. Okay. Calculate the specific latent heat of fusion. Okay, formula dia macam ni. Okay, kita tengok. Latent heat of fusion. Latent heat of fusion வந்து okay, macam ni lah. Dia punya formula dia biasanya ml. Tak apa. Q equal to ml. Heat energy equal to latent specific heat of and time multiply with the mass. And remember, heat energy also equal to power multiply by time. Okay, power multiply by time. So combining this equation, power times time equal to ml. Okay, baik. Sekarang kita nak cari L saja. Tetapi dalam mass ni kita ada M1, M2 kan. So M2 minus M1 lah. Because we want the, okay, kita asal-asal 100, dia jadi 300. Maksudnya 200 gram ais yang telah lebur, melted. So the M2 minus M1 lah. Over. times L. Okay, sekarang jadikan L tu sebagai subjek, PT over M2 minus M1. Tak boleh M1 minus M2. Oh, okay. They put, oh, okay. They put the M1 here, M2 here. Okay, okay, okay. Kejap. Okay, dia cakap, okay, yang ni adalah M2. Ini adalah M1 lah. Dia label macam tu. Okay, 0.3, 0.1. Jadi, M1 minus M2 lah. Doesn't matter actually. Okay. Right. Jadi, latent heat dia macam mana? Power dia 100. Time dia, mesti dalam SI unit. Second, 20 second. 0.3 minus 0.1. How much is that?
$10,000.
10,000. Unit?
Unit
Unit kamu tengok Q equal to ml kan? Betul tak? Make L as a subject, Q over M. Q tu apa dia unit? Q tu apa?
Q2 heat.
Heat unit dia, heat energy.
Q
Joule lah.
joule.
Yang ni kg kan?
kg.
Jadi joule, kg naik atas. Jadi kg negative 1. Boleh Dekat sini dah bagi. Joule per kg. Nampak? Dia punya apa ni? Unit dia. Joule per kg. Okay. Yang ni cuma imaginary value saja. I just show you how to do that. How they get this formula suddenly. Okay. Baik. Kalau kita nak test vaporization, heat of vaporization, LV. Yang ni dia buatlah macam ni. Initially, let's say it is 0.1 kg. After a while, you let it boil. All the water change into steam ready, right? So the water will decrease lah. For example, let's say 0.007. This one 0.10. Let's say lah kg. Time taken, let's say 40 second. And power of the heater is 100 watt. Okay, calculate the specific latent heat of vaporization. Formula yang macam tadi, saya dah tunjuk macam mana kita derive. So, we straight away directly do the substitution. Power dia 100, darab 40, over M1 minus M2. So, 0.10 minus 0.07. How much is the answer?
$133,333.3.
Kalau macam ni, it is best to represent your answer in what?
Standard form.
Standard form. 1.33 times 100,000 kan maksudnya ada 5. Power 5 ke?
5.
5 joule per kg. Contoh lah. Ini contoh dia. Okey, boleh
Okey.
Okey, sekarang kita nak relate. Ini saya dah ajar kamu kan. Q equal to power T. Heat energy produced by the electric heater will be absorbed by the substance. We assume there is no heat loss to the surrounding. So heat released by the heater is equal to heat released by heat absorbed by the substance. Ini kita dah belajar masa kita apa ni, Q equal to MC theta. Sekarang question dia boleh gabung MC theta dengan ML. Okey, bila kita kena guna MC theta, bila kita kena guna ML. Contoh Contoh okey, katakan kita ada satu ice at 0 degree Celsius. Okay, it will start to melt, becoming water at 0 degree Celsius also. And then it becoming water at 100 degrees Celsius first. It will increase up to 100. Once it reaches the 100, it will becoming the steam at 100 degrees Celsius. Can you understand this pathway? Any question with this first?
That means water at 100 degrees Celsius means temperature dia still 100.
Dia akan berlaku serentak. Kan dalam chemistry kan kita dah belajar kan heating curve dia. Dia akan constant for a while and then go up. Heating of naphthalene ada kan?
Ada.
Dekat sini kenapa temperature dia constant? Sebab di situ itulah yang kita cakap latent heat. Itulah latent heat. Temperature does not change, tetapi di sini solid plus liquid kan? The phase already change. Jadi dari segi chemistry kita akan cakap ikut chemistry lah. Kalau fizik kita cakap berdasarkan latent heat. Kita akan belajar benda yang sama je. Tu graph tu. The heat energy is absorbed to overcome the force of attraction. Almost the same thing only. Okay. Latent heat is absorbed to weaken the bond between the molecules. It's the same thing. Kita akan cakap heat energy is absorbed to overcome the force of attraction of molecules. Sama je. Okay. So, dekat sini. Ice becoming water. Matter change. Tapi temperature tak change. Jadi kamu kena guna ml. Q equal to ml. Because this is a latent heat. Sekarang 0 degree Celsius to 100 degree Celsius. Temperature berubah mesti MC theta. Dekat sini kita guna pakai MC theta. Di sini water becoming the steam. Matter change but the temperature does not change. ml lah. Sebab di sini kita panggil latent heat of fusion. Dekat sini latent heat of vaporization. Boleh faham?
Boleh sir.
Okay, jadi conclusion dia macam ni. Kalau temperature dia berubah, immediately use MC theta. Temperature berubah tetapi physical state dia tak berubah. Kalau physical state dia berubah tapi temperature sama, itu yang kita belajar hari ni. Q equal to ml. Okay.
Sir, can go to washroom for a while.
Can.
Sorry sir.
Can. Okay, I also go washroom. Okay. Jom kita bincang calculation part. Can first we do calculation first.
Okay sir.
Because time consuming, we do the calculation part first. Okay. Example 1. Fatina used a heater to supply 300 joule of energy to a liquid. Q lah. If 0.4 kg of the liquid change into gas, tengok phase of matter change after heating. What is the latent heat of vaporization of the liquid? Dia tanya LV. Okay. So Q equal to ml. Dia tanya L. L tu Q over M. Jadi L sama juga Q 3400 joule bahagi dengan 0.4 kg. How much is that?
Great answer.
Okay.
Eight thousand five hundred.
8,500.
Uh, Joule
Uh-huh.
kg negative 1.
Per kg. Very good. Okay, next one. Siti cools a pitcher of tea using ice cubes. If the tea cool down after releasing 10,500 joule, okay, calculate the mass of the ice that has been melted. Mass, dia tanya mass sekarang. Ni Q. Specific latent heat fusion of ice already given. L dia. So Q equal to ml. As usual, M equal to Q over L. So Q dia adalah 10,500 joule bahagi latent heat of fusion 3.34 times 10 to the power of 5. Berapa kg? Yes, berapa kg?
Answer. Wait, answer.
Okay, okay.
0.03 answer.
0.03 ya. Kita kira na ipran 10,500 divided by 3.34 power 5. 0.03 lah. Kalau nak ni boleh ambil lah dua tempat 31 ke. Okay, 31 kg. Okay, next one. Hermione use electric heater with power rating 100 watt 240 to melt some ice. Initially, the mass of the ice is 750 gram. Ice, calculate the time taken so that only 400 gram of the ice cube is left. Kalau 400 is left, berapa yang melt? Mass of the ice that has been melting. $750 gram minus 400 gram. Jangan ambil 400 gram. That is what is left. So, about 350 gram, iaitu 0.35 kg is melted. Okay. So, calculate the time taken if the specific latent heat of fusion is 3.34 times 10 to the power of 5. Okay, as usual, kita
Sir,
buat
PT equals to ML answer. Obvious.
very good. PT equal to ml. Okay. Jadi power dia 100, time dia kita dah tahu. M dia atau kalau kamu nak susun dulu baru ganti pun boleh juga. Mass dia adalah 0.35 and latent heat is 3.34 times 10 to the power of 5. Jadi T is equal to 0.35 multiply 3.34 times 10 to the power of 5 divided by 100.
1169. 169.
1169 seconds. 1169 second. Okay. Next. Irfan used an electric heater with power rating 240 watt 240 volt to melt some ice. Initially, the mass of the ice 2 kg. If the heater is used for the 10 minute, calculate the final mass of the ice. Maksudnya, imagine the mass is not given. Imagine the mass is not given. Dia ambil 2 kg tapi berapa yang melt, berapa yang tinggal kita tak tahu. Dia tanya final mass of the ice. Jadi kita kena cari dulu berapa dia melt. Okay? Right. So, yang ni kena ஜாக்கிரதையா செய்யணும் இந்த மாதிரி கேள்விலாம். Okay, அவங்க கேட்டது வந்து the final mass of the ice, not ice that has been melt. So, PT equal to ml. So, 250 times 10 minutes. You kena darab 60 lah. Mass kita tak tahu. L dia berapa? L dia adalah 3.34 times 10 to the power of 5. Jadi 250 times 10 times 60 divided by 3.34 times 10 to the power of 5 is equal to mass of ice melted. How much is that?
It's getting a large number.
I'm getting small number.
I do agree.
Okay. So dia punya melting adalah 0.545 kg. Yang tinggal 2 kg tolak 0.45 which has already melt. Jadi kamu akan dapat 1.55 kg lah.
Done, sir.
Okay. Example 5. Ini question macam ni kena careful. Careful. Okay, calculate the total energy needed. Q lah. Total energy needed to change 0.2 kg of ice cube into water with temperature of 30 degrees Celsius. It is given that latent heat of fusion is 3.34 power 5 and specific heat capacity of the water is 4200. This problem involves the specific heat capacity and the specific latent heat. Dua-dua pun terlibat. Sebab ice becoming water, latent heat of fusion. Tetapi water will stay water first until reach 30 degrees Celsius. The one we use heat capacity. So student must note that the melting of the ice is 0 degrees Celsius. Ice will change into water at 0 degrees Celsius. The problem is involved 3 stage. Okay, I give you the diagram ready. Initially, let's say the ice is -5. Not starting with 0, -5. Dia dah bagi temperature -5, kita follow je. Kalau dia tak bagi apa-apa, kita assume 0. Okay. So, it melt to the water. So, sorry, the ice becoming, absorb heat becoming theta 2, 0 degrees Celsius. And then it absorb heat. It becoming water. And from water at 0 degrees Celsius, you need to becoming the water at 30 degrees Celsius. So, stage by stage sajalah. Jadi, kamu kena buat satu persatu. Dekat sini, kamu tengok temperature change kan? Jadi, guna MC theta dulu. Dekat sini, 0 degrees Celsius, 0 degrees Celsius, ice becoming water. Latent heat. Jadi, lepas tu, water becoming water saja. Maksudnya, phase of matter does not change. That means, MC theta lah. Another thing you can see the temperature change, right? So MC theta. Jadi the total Q is equal to Q1 plus Q2 plus Q3. Whereby Q1 you use MC theta plus ML plus MC theta. Okay? Right. Kita buat satu persatu. First one, it is 0.2 kg, right? Okay. 0.2 kg. This one all still the water. So 4,200. The theta is from -5 to 0 degrees Celsius. It increased by 5 degrees Celsius. So times by 5. Plus 0.2 times latent heat fusion. Fusion dia bagi 3.34 times 10 to the power of 5. And then MC theta for the water. Water is still 0.2 kg, 4,200. Now the temperature change is 0 to 30 degrees Celsius. So 30 degrees Celsius. How much is that?
$96,200.
Very good. 96,200 joule. Kita boleh express 9.62 times 10 to the power of 4 joule. Okay, you can do this type of question already, then okay lah. Okay, exercise 6. Dah habis
That's a
Okay, come. Now, normally they will give you this kind of question lah. Graph question. Diagram show the heating curve of 0.2 kg solid X when being supplied with heat energy from heater with power rating 200 watt, 240 watt. State the 1 minute. Hello. Yeah. Yeah. 5 4 8 ஒன்று. Oh, sorry, Safrina. What is the melting point?
60 answer.
Yeah, 60. இந்த இடம் solid. இந்த இடம் தானே solid plus liquid இருக்கு. அப்ப இங்க தான் melting நடக்குது. Melting நடக்கும்போது temperature மாறாது. Because heat energy is used to overcome the force of attraction first, to break the force. So 60 degrees Celsius. Question B. Calculate the specific heat capacity of solid X. Okay, specific heat capacity na MC theta solid னு சொல்லிருக்காங்க. அதான் keyword. Solid na இந்த சைடுல தான் solid இருக்கு. So this side lah MC theta. So mass dia 0.2 kg. Specific heat capacity. C வந்து அவங்க கொடுக்கல. நம்ம தேடணும். அதுதான் C தான் தேடணும். So Q equal to MC theta. Dia tanya specific heat capacity which is C lah. Q over M theta. Okay, Q over M theta. So the Q na வந்து PT lah. Kita boleh guna yang tu juga. PT over M theta. So power is 200. 30லேருந்து 60 போகுது. So 30 second. Secondல தானே இருக்கு. Okay. Sorry. Silap pula saya. Itu bukan, itu temperature kan? Time dia dekat sini. 0 pergi ke 35. So 35 second. Mass dia adalah 0.2 kg. Theta dia adalah 60 tolak 30, which is 30. How much is that?
Wait ah.
Iru வரேன். 8 No.
No, I said wait ah.
Oh, wait. Okay.
1166.67 ah.
66.7 lah.
Ah.
Okay, dia punya unit. Kena tahu. Q adalah joule. Mass dia adalah kg kan? Kg kita tolak 1. Theta ni degree Celsius tolak 1. Betul?
Betul?
So you just follow that. J kg -1, degree Celsius -1. Macam tu. Okay. Right. Next one. This one, careful, this type of question. Okay, C. Latent of fusion. Kalau dia cakap fusion, melting lah dekat sini. Kalau dia cakap fusion, melting. ml. Okay. So, dia tanya specific latent heat. Maksudnya Q equal to ml. Power times time equal to ml. Dia tanya specific latent heat of fusion tu L lah. PT over M equal to L. Jadi L dia adalah power 200. Time dia 35 until 75. So 40 second. Over mass dia 0.2 kg. Berapa jawapan dia?
$40,000.
Ya, 40,000. 40,000 unit. Dah lupa tu. Joule per kg. Okay, next. Explain why the temperature between 35 to 75 stay the same even though heat is still supplied to it. Macam soalan chemistry pula. So 35 to 75 is still the same because we use the energy not to raise the average kinetic energy, but we use it to break the bond between them. Okay, yang tu kena belajar dekat sini. Okay. So latent heat absorbed to weaken the bond between molecules. Kinetic energy molecule is constant. Temperature is constant. Yeah, okay. Bahagian ni saya explain next week lah. Okay, bahagian ni saya explain next week. Okay, kita ada, masih ada calculation lagi sikit. Okay, we will continue this part on next class. Okay, that's all only for today. See you on next class.
Okay, so thank you, sir. Bye.
Okay, bye. Take care. போன வாரம் அவன் அங்க உட்காந்தால